Hello and welcome to Rapid C++ Development, combining Embarcadero C++ Builder with Microsoft Visual C++. Your instructor is Rob Swindell, Embarcadero MVP.
In this video, I'm going to be demonstrating how to integrate externally built object files with your C++ Builder application. To do this, I'm going to be using the C++ Builder IDE, known as RAD Studio, also some external source modules, like these that I'm using Notepad here to edit, and then I'll be building those from the command line using 3 different C and C++ compilers. If you're coming from a Visual C++, Visual Studio background, and you're more familiar with those key bindings, you might want to enable an option under Tools, Options, under User Interface, Editor Options, Key Mappings, you have a Visual Studio Emulation option. So if you're more familiar with those key bindings for, say, compiling or linking or setting breakpoints, then you might want to use that option. So the sample external code that I'm going to be using is very basic, just this function that returns an integer, and I chose the magic number 42. I have a C++ and a C version. Currently those are exactly the same, and then a header file that declares the function signature. To use this, you first want to create an application. Let's go ahead and create a Windows VCL application. That's your most basic application that's kind of a blank slate and targeting Windows only. And what we're going to do is insert a label. And I'm going to rename it just label. And I want to make it bigger, more legible for the video, so I'm going to change the font size here. I don't want a default caption, so I'm going to delete that. And then I'm going to double-click my form that's going to create an event handler for the form create. So every time that form is created, this code is going to be executed. What we're going to do is set that label's caption to the integer value returned from that C function I showed earlier. Now, although this caption is a Unicode string, a special C++ class, VCL class, has an overloaded assignment operator, so it can convert from integer to text no problem. And when I try to compile this, it's not going to know what return int is, so I'm going to need to include that header file where I declared that function. And it's not going to know how to find this header file unless I tell the project settings that I have another directory where include files can be found. And that's under the C compiler, directories, include, search path. Now, this should compile, but it's not going to link because it's not going to find this symbol. But let's go ahead and compile it, the traditional IDE Control F9 command that does a make. So here's our linker error, unresolved external. How we add an object, an externally built object, we right-click on our project, say add, tell it we want an object file. And then we'll go ahead and go with the C++ built. So the different compilers used here, this is the going to be the object file built with the traditional or classic Borland C++ compiler. This is the Clang-based compiler, that C there indicates the new Embarcadero Clang-based C compiler, C++ compiler, and then of course we have Microsoft Visual C. So I'll go ahead and choose the traditional. When you create a new project, the default is to use the new Clang compiler. You can change that if you like. If you have a preference for the older compiler, is here. Use classic Borland compiler, and it's default to false. So if I enable that, it's going to use that BCC32 compiler. Otherwise, it's going to use BCC32C, BCC32X. Those are both drivers for the underlying Clang compiler. All right, it compiled. We run it, and it got a return value from that function. So that object file, while externally built, is compatible with our C++ builder project, and we got the magic number we were looking for. Now, let's say we try to use the Microsoft built object file instead. This is going to fail, and the reason is indicated down here. This object file is not compatible. It's not in OMF format, which is the format that the Embarcadero tools create and use for 32-bit Windows. It's possibly in COFF format, and it actually is in COFF format. So let's get into the details of these object files and why some would be compatible and some may not. So Embarcadero supplies a tool called tdump, stands for turbo dump, and the basic usage is to supply it a file name, and it will tell you the details of that file name. So we'll go with our traditionally C built C module, and then maybe we can do some side-by-side comparison here. Say the C++ built version of that same thing. And the important thing here is that function symbol we're looking for, return int, we see it's different. We have a leading underscore here in the C version with no leading underscore in the C++ built version. So this is the version that we linked with our application and worked. So let's look at the version that didn't. That was the Microsoft version one. Oh, look, it won't support it. tdump by default assumes that you're passing it an OMF formatted file. So you do have the option of specifying -C for COFF format. That's that Microsoft generated format. And it can display our file here. Oh, look here. Here's our symbol we're looking for, return int, and it has this ya xyz or whatever. This is called name mangling or decorating. This is something that compilers will do to C++ functions. If we look at the C version of this same thing, generated by Microsoft, we don't have the name. So even though it's the same source, compiled just with a different file name, so it triggers the C++ compiler rather than the C compiler, you get a very different symbol. So this name mangling, although right now that is not our primary issue, we will need to address that later, so it is important. But right now, the main issue is that this file is in the wrong format. Embarcadero does supply a tool called COFF to OMF. And the purpose of this tool is to convert import libraries for DLLs. If you pass it an object file, it will pretend to convert it. So let's do that. Let's pass it that C++ MSVC file, and the output file is going to be, we'll call it omf.obj. So it didn't complain. It did create our omf obj file, but if we dump that, it's pretty much blank. If we use like a hex dump on it, yeah, there's really no data in here. There's no code. There's no symbols. It didn't really work. So don't be misled. You cannot really convert a COFF format object file to a OMF format object file directly. Let's say you're using a C++ code base, highly likely, and you want to access a class member. So let's define a basic class and make this a public member of that class and call it static so we don't have to instantiate, and that's all we need. And then in our C++, we're going to say that it's a class member, and we need to include our header file so that we get the class definition. So previously, had very simple names. It was just that return int, like so. But now that we've rebuilt it as a C++ class, we get actually a class name in our exported function name here. To use this in our VCL application, it's compatible. It works. But let's look at what Microsoft did with that symbol name. Microsoft does have an equivalent tool called dump bin. It only supports COFF format, but let's go ahead and use that as an example. /symbols, CPP MSVC. And now we see a highly decorated function name here. So this is not going to be directly compatible with C++ Builder, even if we could link it. So the linking issue we'll solve later, but the symbol name issue is still here. Now if I wanted to do this in a FireMonkey application, that's the multiple device framework, it'd be very similar. I'll go ahead and demonstrate that. So I'm going to do a new multi-device application. And again, I'm going to drag a label. The object model is very similar, although not identical. So some steps will be a little bit different. So again, I want to make this large. So that's under text settings, font, size. Set the default, I'll make it big. And we see here that it's kind of being truncated, so we want to set this auto size property to true, so it accommodates the size we want. We don't want a default text. In our name, we want to set to just label. Again, double click to create your form create. Event handler, label text equals basic : return int. Again, we need our header file. We need it included in our project. The directory where our header file is stored. And we need to add the object file that is compatible. Voila. So this is a FireMonkey or multi-device application. You can target lots of platforms, iOS and Android and Mac OS, with the same code base, very similar framework to VCL. Although the symbols are compatible here, and our object file is compatible and we're linking, it is possible that we could have a calling convention mismatch. You can also have linking issues when you change the default calling convention of your built object files. So it's best if you're going to be exporting symbols from a C module to explicitly state the calling convention in the header file. That would be done like so if you're using cdecl or standard call, like so. Now, the issue with object file compatibility also applies to libraries. Libraries are collections or archives of object files. So if you use a tool like the Microsoft lib utility or the Embarcadero tlib utility to combine object files into a library file or a .lib file, you could have the same issues with compatibility. You need OMF format library files to be linked using the Embarcadero tools. Even though the file names have the same extension, .obj or .lib, don't be fooled. You do need to look more closely at these files. And again, the symbols, the calling convention need to be compatible. And the symbols can be affected by C++ name decorating, the calling convention, command line options. All these things can affect the symbol names that are exported by the generated object files and library files. All right, so we have a working application that uses an externally built object file using Borland tools, but we haven't been able to do that with Microsoft tools. The way to do that would be to create either a DLL or a COM object that we could call functions in or access data from. We're going to be demonstrating in the next segment how to create a compatible DLL using Visual C++. Reviewing what we went over in this video, we created applications in C++ Builder which linked with and pulled data from externally built object files. We did this with a VCL application for Win32, as well as a multi-device application using the FireMonkey framework, also for Win32. We demonstrated how object and library files linked with C++ Builder applications must be in OMF format, and how to use tdump to dump the details of object files and library files, both in OMF and COF format. Also, we covered that the COF to OMF utility supplied by Embarcadero cannot be used to convert object and library files from Microsoft COF format to the compatible OMF format. In addition, we detailed what can happen with exported symbol names based on the type of compiler used, or the mode of the compiler, the type of source code, the calling conventions of the functions, whether or not you're exporting a C++ class member versus a global function, and the name mangling methods chosen by the tool vendor. We also alluded to the fact that there is a solution to this object and library format problem, and that is DLLs. We'll be covering that next.